Hello everyone, and thank you for joining me again for this live lesson. Together we'll discuss more about decisions and how we take decisions based on different conditions in our code. And before starting, as always, I would like to take the opportunity to advise you to share this channel with others and to subscribe in case you haven't done this already. And if you have missed the first lessons, you have a lot of you have them already recorded here, and you can find them on the channel. And beside this, you have a lot of other videos that you can see as well. So let's start with decisions, and for that I will have to create a new project. So let's create a new Java project using version 12, and let's call it OCA lesson 3. And we should have the project here, in which, as usual, I will create a package. Let's call it main. And inside the package I will start with one class, example1. And the first thing that we will discuss is the ternary operator. Before going deeper into control structures and decisional control structures, if, else, and switch, I would first like to show you the way you can take decisions with the easiest element of Java language, that is the ternary operator. And the ternary operator, even if you won't see it very often in practice, it's still good to know it. First, is part of the language as well, and also you will find it in the OCP Programmer 1 and Programmer 2 exams. So let's first analyze the way this is working. So we create the main method here, and when we discuss about decisions, we always need a condition, and in Java the condition is always of type boolean. So let's consider for the beginning that we have the condition, and we don't care how was it evaluated. We have this condition as a normal local variable, and the value is true for the moment. And what can we do with this condition? Well, for example, we can use it with the ternary operator. And the ternary operator, also known as Elvis operator, it looks like this. So you can see you can see that if you look in a specific direction, you can see Elvis' face here. This is why it's called as well ternary operator. Well, in case we want to use this operator, we need a condition, and we need something to be evaluated if the condition has the value true or if the condition is false. So it will be something like we can get the result in a specific variable, and we can use the condition, and after the condition we have the question mark, and then we have separated by column the values that will be returned by the operator for the situation in which the condition is true and for the case in which the condition is false. And let's say we will deliver 50 for the situation in which the condition is true, and 100 for the case in which the condition is false. And this will be the result that will be returned by the ternary operator. Of course, always the type of the result for true will be the same as the type of the result for false. That is, you will always have to store this as a, let's say, return type, and it will be stored in a specific type. So I can't, for example, deliver a string for the case in which the condition is false and an int in condition is true. And in this case, let's also system out print it, and let's see what happens. We already know that the condition is true, so the result will be 50. So will be what is before the column operator here. So let's simply run it. And we will see the result in the console, and the value of the result is of course 50. So if the condition would have been evaluated as false, then we would have the value that is after the column symbol here. And let's run it again to see that as well. And again you can see that in this case you will have the value 100, that is what is evaluated for the condition being false. So now of course that this false and true will not be given directly, so they will be the result of something. That means that, for example, you could have two variables, let's call them x and y, and the condition could have been like x smaller or greater than y, and then this would be based on the values that x and y are provided with. The condition would be true or false. In this case the condition is true because 20 is indeed smaller than 40, so we will see 50 in the console. That is the result of the ternary operator with the condition being true. And also I have split this to be easier to understand for a first example, but maybe in a specific situation you will directly see here the condition given as the expression, so you don't have to provide specifically a boolean variable there. You can specify a condition that can be evaluated by a boolean, true and false. And again, a condition in Java will always be evaluated as a boolean, otherwise it is not a condition. So there are other programming languages out there in which it can be used. You can use an integer, or you can use even an object reference as a true or false. In this case in Java we have the boolean values, and this can be only assigned true and false, and you can only have a boolean type for a condition. So this is why we have to use expressions like this one. We will discuss later about the comparison operators, but the expression that I have provided here, x smaller than y, will always be evaluated with a boolean, so will either be true, either be false, and then this condition is correct, so you will obtain the value from the ternary operator depending on the value of the condition. So in this case, depending on the values for x and for y. And if you want to make this even more dynamic, let's try to read these values, for example, from the console. So there are a lot of ways for doing that, but for the first example I will only show you how to use a scanner for that. A scanner is a class that again we will discuss later in detail, but that we can use to read from a specific input stream, and in this case systemin is the input stream that represents the input from the console, and we create this object of type scanner, and then we can use the nextInt behavior method of the scanner to read an integer. And this is now, I don't know which would be the result. It would either be 50, either be 100 based on the result of the condition. So this is based on what is my input from the console. And you can even do something like let's for example specify that we are inputting a value for x and a value for y. And when we run this example, then we should be asked for a value for x, and let's say we input 20, and then we would be asked for a value for y, and then we input 50, and then we have a 50 because 20 is smaller than 50, so we will have 50 as a result that is provided by the ternary operator. So because x was smaller than y, I got 50, and I have printed out in the console the value 50. And let's run it again and put the values the other way around. So let's say that in the second case we make x to be 50 and y to be 20, and then of course the value that I see here is 100, so it is what we have for the situation in which the condition is false. And this is the first way of taking decisions that you have to know, so the usage of the ternary operator. And you will see the ternary operator in questions for the OCP exams. Moreover, usually you don't use the ternary operator, and even less usual you will see it using nested examples of ternary operators. That is, and I will create a second example for this to keep it separate. So example 2. In several questions of the OCP exams, you might see something like a nested ternary operator. That is where you have a specific condition and then you have the normal ternary operator, but instead of having direct values here, you will have another ternary operator, so you can have something like this. And again, we have this condition that will output 10 or 40, and then for example 50 in the end. So you can see how difficult is this to be read. And first of all, if you have this kind of situation, this kind of a question in your OCP exams, make sure that the data types are okay, so that for this one you will provide a correct data type. You will not have different data types, because in this case you would actually have a compilation error. And in order to make it easier, you'll simply have to maybe try to use some parentheses here. So put some parentheses to separate the operators, and then it's a little bit easier to see and to evaluate the situation. So if you see it like this, and if you in your mind add some parentheses for the other operators that are nested, it is easier to evaluate them. So you can see that this is the condition of the outer operator, and then we have an inner operator here that will be evaluated only if the condition for the first operator is true, and then we have what happens if the condition for the first operator is false. And in this case you can clearly see that the condition is false because 20 isn't greater than 40. That means that this operator wouldn't even be evaluated. You will directly obtain the value 50 that will happen for the false value of the condition. So if you run this example now, you should see in the console the value 50. And of course, in case you would have had used a condition that is true, then this operator would have been evaluated, and then 5 is indeed smaller, so that it means we will get value 10. So you see the value of this condition, and then you know that it will be evaluated what is before the column sign there, and then you start evaluating the second ternary operator, and you see the condition for the second ternary operator is true as well. So that it means it will return the value that is again before the column, that is 10 in this case. So if I run this example in my console, I should see value 10 because both conditions are true. If this condition would have been false, let's say 15 smaller than 10, and this is clearly false, then you would have seen 40 because the first condition is true. Then you evaluate what is before the column, and that's this entire operator here, and then you see the condition is false here, and then that means this operator will actually return 40. And even if they are way out of ordinary and you avoid using this in a real life situation because it's clearly not clean code and it's very difficult to read, so you make your code unmaintainable by using such kind of nesting operators, still you will find this in your OCP exams, so make sure that you understand them and make sure to to do several examples and try to see that you clearly know which will be the result in any situation. See that that you have clearly understood what is behind this ternary operator before going into your OCP Programmer 1 exam. Okay, if this is clear, and don't forget that you can always you can always write me in the live chat, so if you have questions, if I didn't explain well, or maybe you want me to explain again something, you can write me in the live chat, and this is the idea of having the live events, and you can communicate with me, and I can answer to your questions directly. So let's go on further to the third example, and I will create, oh, not a Kotlin, of course, we are learning Java here. So another example class, and this will be example 3, and another main methods here. So if we have already discussed about the ternary operator, then the next thing that we want to discuss is the if-else decision control structure, and this is what I want to present here. We'll call it if-else, and again I will start from having a condition, and again, to make it very clear, I will repeat it several times. In Java, the condition will always be of the type Boolean. So always when you hear about a condition, please check that is it of type Boolean, because if it is not of type Boolean, then it's a compilation error. So you have several questions in your OCP exam, Programmer 1 exam, where you see control structures that should use conditions, but the condition type is not a Boolean. So in that case, for those questions, the answer is pretty clear. It should be the code does not compile. So if the condition is not of the correct type, then the code doesn't compile. So how is it this if else written? Let's start with the if clause that is declared by using the keyword if, and then we have the parentheses in which we always have a Boolean type condition, and then we have a block of instructions that is guarded by these curly braces. And let's assume that in this case I will only print line something in the console, and I will print that is true. And that's because in this block of instructions will actually be executed only in case the condition is true. So you know already here that my condition is true, so that means that this block of instructions will be executed, and then I should see in my console this string being printed. So let's run this example, and let's see that in the console we have indeed printed it's true. Of course you must know, at least for the OCP exam, that you might avoid using the curly braces in case you only have one instruction here. So if you don't have multiple instructions, you don't have to use the curly braces. Well, in a real application, it is advised that you always use the curly braces, even if you have only one instruction, because this makes the code easier to read. And moreover, in OCP exam, you will see questions in which these curly braces are taken out, and you have, for example, the code written in such a way that it might mislead you to what happens. So let's assume the condition is false here, and if the condition is false here and I don't have the curly braces here, then of course you will not see anything printed because this instruction here is executed only for the case in which the condition is true. So our condition is false, so you won't see anything. Let's run it to make sure that this is the case, and you shouldn't see anything in the console. Okay, you don't see the string is true, it didn't appear here. And what happens, for example, in OCP exam questions is that you might see another instruction like somehow indented in a way in which it looks like it's part of the if as well. So like I did with this second system out print line, I've told you. So what happens here is the condition is false again, so this instruction won't be executed. But the second one is not part of the if clause. That is because if you don't use the curly braces, only the first instruction is part of the if clause. So the second one actually will be executed, and this is because I could have written it better without the wrong indentation, and in this case the code was at least easier to read. So if I write the code like this, you can clearly see that this is part of the if clause, and this is actually not part of the if clause. So you can run this example and you will see only this string in the console, but this one won't be printed. So you will see I've told you, but you won't see it's true because the condition is indeed false, so this one will not be executed. But this will happen the same if I indent it like this, and even if the code is executing the same, so you will see again I've told you is printed in the console. The way I have written the code is clearly much more difficult to read, and if you are tired or if you are not attentive, it might mislead you, and you might answer wrong question, and you will see this kind of questions in your OCP exam. So make sure that you are very attentive, and in case you don't see the curly braces, then it means that only the instruction that is immediately after the if clause will be taken into consideration by the if clause. So if I have added now the curly braces here, that means that everything that is between the curly braces, so this entire block of instructions, is executed only when the condition is true. So my condition is false, then it means I won't see anything in the console here. And then of course I will make the condition true again. Sorry, small letters, always small letters. And then you will see that both of the strings are printed in the console. So this entire block is treated by the condition of the if clause. And again, I have created this boolean variable here in order to replace my condition, but in most of the cases you will simply have a condition that is evaluated by true or false, so you don't have to explicitly all the time use a boolean variable as I have done. You can simply have any kind of expression that can be evaluated by true and false, and this is the only condition to have an expression that is evaluated with a boolean value. If it is not evaluated with a boolean value, then it will not compile. So for example, something like if x, this is wrong, this won't work, it won't compile in Java. If x is you can see here that it is shown by my IDE that it is a wrong condition, and the reason for that is that x is an int, so you can't make an int type condition in Java. It should be any kind of expression that is evaluated by a true or a false. It should be evaluated with a boolean. Okay, this is what's happening for the case in which the condition is true, and you can have only this if clause. That means if the condition is true, what is designed to be part of the instructions of the if will be executed, and if the condition is false, then nothing will happen. You can always, in almost in any IDE, use the functionality of the debugger, and this is a great functionality that you can use to see what happens instruction by instruction. So for example, in my example here in my IntelliJ, I can use this breakpoint that I simply place on the line I want to start debugging with, and then instead of running directly my example, I will ask IntelliJ to debug the example, and let's see what happens. You can do this with any IDE. So if you don't use IntelliJ, this is not a problem. You can do this with Eclipse as well. You can do this with NetBeans. You can do that with BlueJ. Almost I think any IDE has this functionality. So I want to show you the functionality with the debugger so that you can see it step by step as well. So when I have started the debugger, then you see that the execution stopped exactly on the line where I have placed the breakpoint, and now I'm here on this line and this is not executed, and you can see as well the console here again that is empty. So you have the options of stepping over each instruction, and you even have the option in which you can go inside one of the instructions. You usually step over each instruction, so let's use this step over button. It also can be used with the F8 button on the keyboard, but I will use the button on the graphical interface so that you can see what I'm doing. Otherwise maybe it would be more difficult for you to know what key on my keyboard I'm pressing. So let's step over, and when you step over an instruction, you usually see in any IDE what is the value for your variable. So for example, you can see on the right side of my declaration here that x has now the value 5, and you can see again now I have step over again, and you can see that x has the value 10, and now you can simply evaluate this expression here. It's x smaller than y, x is 5, y is 10, so this means that the instruction x smaller than y is evaluated by true. And you know, if I step over once again, the next instruction that will be evaluated will be the print, the first print in the console. So it simply entered the if block just because the condition is true. And if I step over this one, you will see already in the console the it's true has appeared. And then if I step over again, I will see the second one as well, and then I can simply just run until the end. That means I've finished my debugging session, so I've seen what I wanted to see. And of course, what you will see, I will keep the debugger here, and let's say I have 15 instead of 5. So now the condition of course will be false. So let's execute again with debugger, and when I execute with debugger, first it will stop on the first line, and then I will go to the console here to see the result, and I will step over the first, x has value 15, I will step over the second, y has value 10, and then I see that 15 and 10 here are the values for x and y, and that means that the condition for the if is now false. And if I step over this, then you see that it didn't any longer go into the block of instructions for the if. It simply went directly to the end of my program, because when the condition is false, then the if block is not executed anymore. So I can simply run until the end, and of course I won't see anything in the console in this case. and this is exactly what we were expecting to see. Good, I hope this is clear for you until now. Now I want to complicate a little bit the things, and let's create this in another example. I will show you how can we do to execute something when the condition is false, and then we have the else block of instructions that can be added to if, and that means you want to specify something to be executed when the condition is false. So example 4 is here again with if else, and then I have again the x with a value, the y with another value, and we have if x smaller than y, then we simply print in the console the string it's true, and then I can add this else here, and I will print is false. And again, regarding the else, it is the same situation. You can avoid using the curly braces if you have only one instruction. You will usually see this in your OCP questions in the OCP Programmer 1 exam, and you can have both of if and else without curly braces, but then again, be very careful. Look what happens if I have two instructions here and I have an else. Then this doesn't compile anymore, because you can avoid using the curly braces only when you have one instruction, so you can't have multiple here. So it can be even that the code is not compiling when you don't use curly braces. For example, if you try to use multiple instructions for if, then the else will cry that something is wrong there, and it will not compile. And as I said, usually in a real application we always use the curly braces to make the code easier to read. The maintainability of the code is one of the software qualities that is very important for us, and you will learn this with experience. But for the OCP exams, you have to actually know almost all the syntax rules. So that means you must know what happens and when you can avoid using the curly braces. Good, now let's go to the functionality again, and I will keep the curly braces. And what happens here is that x indeed is smaller than y, and that means the condition has the value true, and this will execute the is true, and this is what we will see in the console. When we have an if-else set of instructions, it will be either the if block, either the else to be executed, and it's very easy. This block of instructions will be executed when the condition is true. Otherwise, if the condition is false, then you will see the else block of instructions being executed. So again, running it without a debugger, you will see for this set of numbers here that it's true will be printed in the console, and if we change the numbers such that the condition is false, then we will see the other string in the console, the one that's coming from the else branch of execution, and we will see actually it's false. Okay, and now let's take it step by step with the debugger. So I can use the breakpoint. I can place the breakpoint on my first instruction here, and then instead of running it directly, I will run it using the debugger. So the execution will stop on the line where I have placed the breakpoint, and then I can step over again. I see the values that were assigned to my variables here, and then I know the condition is false, and being that the condition is false, when I step over again, I will see that the else block is executed, and then in the console, after I step over again, the it's false string will appear, and then the program is ending, and I can skip everything else. We can again change it to a condition where I will see that it's true in the console, so the condition now is true. So if we run it with the debugger again, when the condition is true, we will see the execution is stopping on the first line, and then I go and I see the value assigned to x, the value assigned to y. I see that the condition is true, and then I see that the execution stepped into the if block. So when I step over again, I will see that it's true is shown in the console, and then everything was skipped until the end of the program, and this is the execution flow for a complete if-else. Again, I hope this is clear with the if-else, and we will see this structure in a lot of our examples from now on, and it's very important. It's one of the most used control structures, so it's very important for you to understand it, to learn it, and be very careful with these curly braces when they are on, or when they are not used. A fifth example, and I want to show you that in the if or else you can write almost anything you can write in a normal block of instruction, and that means you can have these control structures nested as well. So the fifth example for today, and I have a PSVM, okay, and again I will declare a y, x, y, and z, and what you can do is something like if x smaller than y, then you can say if y smaller than z, then do something, and then you can have an else, and this is where you have to be very careful when you are not using curly braces. And again, in a real application, always use the curly braces, please. This makes the things more easier to and more readable. But in the questions for your OCP exam, you will see situations in which this is not happening, and you will even see situations in which, for example, this would be incorrectly aligned. Of course, IntelliJ doesn't let me do very easy this, but you can see something like this, and this makes the things very hard to understand what really happens here. For example, if x isn't smaller than y, so you might have the value 50 for x here, and you will have the value 20 for y here, so this makes this condition to be evaluated as false. And let's run this example and see what's happening. So when you will run this set of instructions, you will see that nothing is printed out in the console. So maybe in this case you would have expected to see the string b in the console, and this is because I have placed it I have written the code in such a way to mislead you to believe that this else is the else of this if here, but this is wrong because I haven't used any curly braces, and in fact this else is actually of this if here. So the reason for why you don't see anything in the console is that here this if actually doesn't have any else. If you will run this using the debugger, you will see this more clear in the execution. So you will see that with the debugger, when we step over, we have the values for the variables, and then we have the values for x and y, and we know the condition is false, and when we step over again, it goes directly to the end of the program. It will execute this if else only for the case in which this condition is true. It doesn't matter how you write the code. It doesn't matter that you indent the else like that, like being as of this if here. It's still part of this if here, and it will not execute for this one. So this could be very misleading, and you have the chance to see this kind of written code in your OCP Programmer 1 exam. The easiest is to, again, if you encounter this kind of code in your OCP Programmer 1 exam, just put yourself some curly braces to make things easier. So just imagine those curly braces and add them in your mind, and then even if you have this kind of indentation here and this kind of code writing, if you add the curly braces correctly, you will understand better the code, and there are less chances that you will miss the question. But be very careful with these kind of situations if your intention is to take that OCP exam. Good, and this is with if-else, and again, as we will see them a lot in the next videos and next lessons, I think everything that I have explained about them is enough for now. Only if you have questions, again, I always have an eye on the chat, and just ask if I haven't explained correctly something or enough clear. I will try to do it again. But I think we have at least covered what if-else is and how to use it, and we have seen how it's working. So we can go to the last control structure for today, that is again a decisional control structure, and that is called the switch. So let's create an example 6, and in the example 6 I will use a switch that looks a little bit different than a normal if-else, and moreover the switch was changed starting with version 12, so we will have to cover also the new syntax for the switch. But if you are now at this moment of recording the video and the live event thinking of passing the OCP exam you have, the last OCP exam is for version 11, and that means that you will not see the new syntaxes that were introduced with version 12. And even more, in version 12 they are still only experimental, so they for the syntaxes of switch that I will show you for version 12 separately, they will be made general available probably in the next version of Java, so starting with version 13. So that means you will not see them in your OCP 11 exam. You will see them probably when the next OCP version of exam will appear, and that is probably for the next long-term supported version of Java. But let's start with the old syntaxes, and this is something that you have to know for your OCP exam. And if we have time today, if not, we will continue in the next lesson. I will show you also the experimental at the moment in version 12 syntaxes of the switch control structure. And if you are very eager and you don't want to wait till then, I have already actually recorded some videos on the channel. You will find them about the changes for version 9 to 12, and you can see the experimental syntax of the switch also in those videos, so you don't have to wait for me to show them live. Okay, regarding the switch, it's also control structures for decisions. So now we will actually take decisions in regards to the value of a variable, and the type of the variable that we use has to be either an int, either a char, a string, and an enum. And we have already discussed about what an int is, what a char is, what a string is. Even if we didn't discuss the string in details, we have discussed a little bit about string also in the last lesson that I have made live, and you can find it recorded on the channel. And in the future we will discuss what an enum is as well, because it's one of the structures that we will develop with Java, and you will use it in some situations, and you will find it also in your OCP exams. I think it's in the Programmer 2 exam, actually it's not in part of the Programmer 1 exam. Good, so what we have is actually we have a variable, and the variable has a value, and then we use this keyword switch, and between the parentheses of the switch you don't have a condition, so be careful. Despite what we have discussed in regards to if and the ternary operator, where you have seen that between the parentheses we have used a condition, and the conditions in Java are Boolean. In the case of switch, the variable used between the parentheses of the switch, it isn't a Boolean, it actually can't be a Boolean. So you will see questions in your OCP Programmer 1 exam where the switch has a Boolean here. If you see something like this, then the answer for that question or for those questions is very easy. It doesn't compile. The switch compiles only with a variable of type int, char, string or enum for the moment. So in this case actually you can't even use a Boolean. You can use only a variable of the type that is one of the 4 types I have added in the comment above. And let's say we have this value 10 of an x of type int. What can we have in the switch here is cases. So I can say, in case the value of x is 1, do something. Like print a. We always add a break instruction. That is a keyword again we will use from now on to specify where the switch should end the execution. And what happens here, for example, for this specific switch that I have created, this will evaluate the value for x, and x has the value 10. So the switch will use the value 10, that is the value of x at the moment of entering the control structure, and it tries to find value to match the x here. And in my case here, the only case that I have is value 1, so it won't match the value. That means it will actually do nothing. It will skip completely the control structure, and you won't see anything in the console because we don't have any case to match with the value of x. And I see the question now from Christian, if it can be also of type byte and short, because here I have only written int. And the answer for this question is, the reason for why you can use byte and short is because they are promoted to int. So it actually theoretically can be of the type int. If you use a byte, then switch automatically promotes the byte to an int here, so it makes an automatic conversion. And it can do an automatic conversion from byte and short to int because byte and short are smaller than int, so the precision is not lost. Byte has only 1 byte and short has 2 bytes, while the int has 4 bytes. So theoretically, int will be the value of the variable used by the switch. But if you use a byte, Java will automatically convert the byte to an int. So that's the answer. Perfect. So remaining where I have written my case here, if the value is 10 and I have the case of value 1, then nothing will happen. But I can have a lot of cases here. I can have as many cases as I want. So let's say that I will also add the case for the value 10, and in this case I will choose to print B in the console. And let's see what happens in this case. Well, because the value of x is 10 and the switch has the case for 10, the switch will start the execution with the case 10 and will execute everything from the case label up to the first break or to the end of the structure. So you can say that the last break here that I have added is not mandatory, because anyway the switch was ending after this. But in case I would have had something else after, I would have needed to use mandatory the break. Otherwise, even if it is another case, the switch will not stop and will execute everything that's after, the way I will show you in the next example. So you can see for this case it was printed B, and to make it even more clear, let's again go with the debugger step by step and see what's happening. So I will start the debugger, and the debugger will start on the line where I have placed my breakpoint, and that's the assignment of value 10 to x, and I assign the value 10, and I step over the assignment. X has value 10, and because x has value 10, switch will choose case 10 for the execution, so the case for which the value matches with the value of the variable, and then it will print B, and I can see B in the console, and then everything has ended. So this was the end of my program. Now let's see what happens if I have also here a case 15. So if I have also case 15 where I will print C, then if I have added a break here, I will only see B in the console. And again, let's run it first without a debugger, and you can see B appears in the console. And let's now run it with a debugger to see it step by step, and you will see that case 15 is skipped. So it will go to the switch with x being assigned with value 10, and then it simply enters the case 10, and we can see that system out print line B will be executed, and we execute that, and we see in the console here that B appeared, and then break comes, and it will go directly out of the switch to the end of my program. So when break is encountered, break means get out of the switch. So this is the purpose of adding a break. You want to specify when to stop the execution of the switch. If I don't have the break here, then I will see in the console both B and C. And the reason for that is that even if here we have another label, switch doesn't care about that. It will simply execute everything from the start, and the start will always be identified by the value of the variable at the moment of entering the structure, and it will execute everything until it finds either the break instruction or the end of the structure. So in this case, if I don't have a break, it will start the execution by this line that will print B, and then we'll continue with this line that will print C, and then we will have the end of the structure and the end of the program. So you can run it first without a debugger, and let's see what happens, and we should see B and C in the console, both of them. Okay, you can see B and C in the console. And now let's run it with a debugger as well. So again, we go directly to case 10, then B is printed in the console, we can see B, and you can see how the execution stepped directly to this system out print line of C. So even if we have the case 15 label, this doesn't matter, the execution doesn't stop for the switch until it is break is found or the end of the structure. So then C will also be printed, and then we have the end of the program. So this is why when if I want at some point to specify the end of execution, I have to use the break instruction for that, and this is how switch is working. As you can see here now, if I have in my case the situation of value where I don't have any case in my switch, then nothing will happen. Why you can't have dynamic values in the cases? Well, this is something. This is how Java was actually implemented. The cases here should be constants. So I can't tell you something more about this as an answer. I can only tell you that this is how Java was implemented. So we have a variable expression here, and then you have constants here. So the constants for each case. So Bogdan, this is my answer. Actually, I don't have it. This is the way the language is working. And the last thing, I hope I was yeah, I hope this answers your question. Now, the last thing I want to show you regarding a switch is what you can do. What can you do if you want to execute something for any other value than the specified cases? Because if you have a value and you don't have a case specified for that value, then nothing will happen. So in this case, the switch will do nothing. We will simply skip the switch until the end of the program, in my case, because I have nothing after this. If you want something to happen for any other value, then you have or you can use the default case. The default case can be used anywhere. It's not only it can be used, you can put it as the first case, you can put it somewhere in the middle, but usually you will see it at the end. Generally, in practice, we add the default at the end because it's some kind of for all the other cases. So you want to see the cases, and then it's easier to see the cases, and then you know the default is all the other cases. That's why when you use the default, you don't have a value, because the default means for any other value. So if I print a D here, that means that, for example, for value 50 in my case, because I don't have any case that matches value 50, then the default will be executed, and that will print in the console D. In the OCP exam, in the questions, you will see the default being used between the cases or at the beginning, and you can see this kind of syntaxes that are not really realistic for a real application, but you have to know that this is possible and it works similar. So it's okay to have the default, like I don't know, before a case or before or at the beginning of the structure. You will usually see this only at the end in a real life application to make the things easier to read. And again, as you have seen from the beginning of my presentation of the switch, the default is not mandatory, so you can skip having it, and in this case, if you don't have it, nothing will happen. The switch won't execute anything for the value that doesn't match any of the cases. So this is actually how switch is working until the version 9, no, until version 11, actually 11 including 11, and then it was changed starting with version 12. But with version 12, again, this will not be part of the OCP 11 certification, and again, still in version 12, that is the last version, it is only experimental. So it is not considered to be general availability, and you have to add a parameter at the execution to be able, at the compilation and the execution to be able to use it. I will make a very short, and I will end with this last 7 example. And just to show you a little bit, to give you a taste of how the switch looks like. Again, you can see my other videos out there on that I have recorded on the same channel regarding this switch, and I will show you more details about this in the next live event, because we don't have a lot of time left for this event. But as an idea, in the changes that were made for the switch in version 12, first of all, allow you of different syntax. You can have a case where you can use multiple values, and then for specifying the instructions, you will actually use this this arrow here that is very similar to the operator that you will learn to use for expression for lambda expressions. As you can see here, my ID tells me that I need to have supported language level 12, so I think I can do something like this to set the language to 12. Okay, and you see that this is a correct syntax now, because I have version 12 as the JDK added to my project, and I have set up it for execution as well. So it looks a little bit different. You don't have a break anymore, you don't need a break anymore. You can have multiple cases in which you specify instructions. And the reason, one of the purposes for this change is that now the syntax is shorter. You can see that is shorter. You can have multiple values for a case, and to do this you only need to separate the values by comma. In the normal switch, if you want to have multiple values, you actually have to specify multiple cases one after the other. So if you want to have 3 values, let's say 11, 12 and 10, then you have to say case 11, case 12, case 10, and then what you want to be happening for all 3. And you see that the syntax is a lot more verbose to write like this. So now this means that for 11, 12 and 10, this is what will happen. In the case of the new switch that we will have actually generally available from version 13, I think it's a little bit easier to specify. You can see that this was specified only on a row. And moreover, with this switch, you have also the possibility to use it as similar as you have seen with the ternary operator at the beginning of my presentation. So you can make the switch actually return a value. So this will be something like case x is 10, then return value 100. Case x is 11, then return value 200. And this is a little bit different than again what we have, what we were expecting. And because I use it as an operator, I need also a default here to cover all the values. And that means if x is 10, then y will be 100. If x is 11, then y will be 200. And if x has any other value, then y will be 300. And you can see that is very, very similar to the ternary operator that I have presented in the beginning of this presentation. But now with the switch you can have multiple cases, and in a ternary operator you can only have a Boolean expression that will be either true or false in Java, and you don't have the opportunity to specify for 10, for 11, for 15. You don't have the opportunity to have specific values and multiple cases for which you want to get a specific value, and that is what will be possible with the new syntax of the switch. That is again from 12 it's only preview, and hopefully it will be general available in version 13. I think we can end with this for today, and I don't want to give more details. You can see all the details in the other video that I have recorded, and you can find on this channel about the new syntaxes of the switch. And what I wanted to cover for today, I think I have already, regarding the ternary operator, if else, and the switch. And we have done multiple examples with them, and we have also parsed the code using the debugger, and hopefully that all of you have understood all the syntaxes, and even if you maybe won't remind all of them from now, you will see them starting from now on in all the next examples in the next lessons, so don't worry. We will do a lot of examples with them, so at some point until the end of our videos you will for sure remind everything. Again, if you have questions, don't forget that you can post them in the live chat. And please share the channel with others that you might think are interested in Java and learning Java. I have posted here lessons for beginner level, for intermediate, and we'll have all kind of seniority videos recorded. This is my plan with this channel. So share with others, subscribe if you haven't yet, and again, thank you very much for your attention for today. Hopefully it will help you, it's helpful, and it will help you in the future for your target. Thank you again, and hope to see you soon. Bye bye.